Hello friends, this video on number systems part 2 is brought to you by examfear.com. No more fear from exam. The next came the concepts of rational number. Let's understand why rational number is required. So let's assume that you have one pizza and this pizza is divided among 3 people. 1, 2 and 3. Now tell me how much share each person got. So if you actually calculate, let's suppose this is person A, B and C. So lady A got 1/4 of the pizza, lady B got 1/4 of the pizza and lady C got 2/4 of the pizza. Right? Assuming there was 4 portion, 1 portion to lady A, 1 portion to lady B and 2 portion to lady C. So 1/4, 1/4 and if you actually calculate, this is 1/2. So half of the pizza is for girl C and quarter each for girl A and B. So how to represent these quarter and half? This is quarter and this is half. How to represent this number line? If you see, these numbers will somewhere be here, right? The red dots. It will not be in this black scales. It will be the red dots somewhere middle, right? These numbers are called rational number and denoted by Q. First, tell me why it is denoted by Q. Why not rational number by R? Because Q stands for quotient. And the rational number, actually, this rational number word came from ratio. Please know, this rational number word came from ratio. Ratio means something which you can write in the form of P by Q. Where P and Q are integers and Q obviously should not be equal to 0. So if you make Q is equal to 0, this becomes infinite, right? So if you see, this is a rational number, came from ratio because on the P by Q ratio, and it is all quotient, right? So this is rational number. It came from Q, came from this quotient. Okay, so this quarter, half, these kind of concepts we can actually represent using rational numbers. So you see 1/4, 1/2, these are examples of rational numbers. Okay. Have you ever imagined that there can be infinite rational number between two rational numbers? Let's see what I'm talking about. Let's take any two rational number. Let's take 1 and 2. 1 is a rational number and 2 is also a rational number, right? Because 1 you can write as 1/1 and 2 you can write as 2/1, correct? So if you see 1, because 1 and 2 are typically natural numbers and we know that all natural numbers has to be a rational number. And also you can write this 1 as P by Q form. Now let's see how many rational numbers I can have between 1 and 2. Between 1 and 2 I can have 3/2. 3/2 is between 1 and 2, right? 3/2 is what? 1.5. Or the best way to deal with this is, what we can do is, let's write 3 or 4 or 5 zeros here. And here also you have to write 5 zeros. Here also you have to write 5 zeros. Okay? Sorry, 4 zeros. Or let's write only 1 zero. This is 1 and this is 2. So let's multiply by 10/10 and this also multiply by 10/10. So what you get here is 10/10 and what you get is 20/10. So now tell me how many numbers are there between 10/10 and 20/10. There are so many actually. If you can write 11/10, 12/10, 13/10, 14/10, 15/10, right? Then we have 16 by 10, 17 by 10, 18 by 10, 19 by 10. All these are numbers are between 1 and 2. Similarly, instead of multiplying by 10 by 10, if you multiply by 100 by 100, for example, I'll show you 1 by 1 into 100 by 100, you get 100 by 100. And similarly, 2 by 1 into 100 by 100, you get 200 by 100. So if you keep this part constant, between 100 and 200, you can write so many numbers, 100, 100, 200, 3. So similarly, the number between so many rational numbers are there between 1 and 2. That is, in this case, you can say 101 by 100, 102 by 100, and list continues till 199 by 100. Correct? And all these numbers, if you see, are rational numbers. And similarly, if you multiply by 1000, you get all the more numbers. So between any two number, if you take, you will find infinite number of rational numbers. Right? So hope you understand the concepts here. So we took an example of 1 and 2. Between 1 and 2, we showed that these many rational numbers exist. If you multiply by 10 by 10, if you multiply by 100 by 100, these many rational numbers exist. If you multiply by 1000 by 1000, you will see all the more rational numbers, and you can multiply by any number. Right? You can multiply by 1 lakh by 1 lakh as well. So with this exercise, we can conclude that between any two rational number, there are infinite number of rational numbers. So the question says find 5 rational numbers between 1 and 2. Pretty easy. This is 1, this is 2. I can write in the rational form p by q and multiply both with 10 by 10. Why 10 by 10 only? Because I have to find only 5 rational numbers. So this becomes 10 by 10 and this becomes 20 by 10. So I can write 11 by 10, 12 by 10, 13 by 10, 14 by 10, 15 by 10. All these are 5 rational numbers. In fact, you can take any of these rational numbers, right? So this is not the only answer. There can be so many answers for this question because there are unlimited or infinite number of rational numbers between two rational numbers. Okay. We talked a lot about rational number. Let's talk about irrational number. See, rational number, we told something which can be written in the form of p by q, where p and q are integers and q is not equal to 0. Why q not equal to 0? Because if q is equal to 0, any number, let's suppose 3 by 0, this is infinite. So the denominator should not be 0. This is not defined. So this is the definition of rational number. Irrational number has just what you call a negation of this definition, that is number which can't be written in p by q form. So numbers which can be written in the p by q form is rational number. Number which can't be written in the p by q form is irrational number. For example, if you have a irrational number 5.27328916053 right, 80789, some number, right, list continues. So this is the irrational number if there is no pattern which is same and the list is, this decimal point is infinite. Like root 2 is a good example of irrational number. Pi is a good example of irrational number. We say root 2 as 1.414. That is, we can't say root 2 as 1.414. Actually, root 2 is approximately 1.414. I hope you understand the difference between equal to and approx. Because root 2 is not equal to 1.414. Just for our ease of calculation, we say root 2 is 1.414. Similarly, pi is not equal to 3.14. Just for our ease of calculation, we assume pi as 3.14. Actually, pi, if you see, if you try to actually find the value of pi, the list continues. We have so many numbers here, right? But if you can write something in the form of p by q, that is rational number, where p and q are integers and q is not equal to 0. If you can't write something in the form of p by q, where p and q are integers and 2 is not equal to 0, then that is irrational number. Okay, pi, root 2 are a good example of irrational number. In fact, root 3 is also a good example of irrational number. See root 3, this is also a good example of irrational number. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.